Okay, so let's take a look at our derivatives and integrals of transcendental functions project. You have a part one and a part two. Part one is logs and implicit functions. The name of part one should give you a clue, really as to, or maybe even some hints as to how to specifically, implicitly um, take the derivative. So just take a look at those. You have your left side of your equation and your right side of the equation. So use the properties of laws somewhere in your work. I think that you will find that that helps you in implicitly deriving both sides of that equation. And it does say here that your y prime can be in terms of x and y. So you do not have to isolate y prime. Excuse me, all the y's on one side, all the x's on one side, or anything like that. Just have the y prime equals whatever. And you also do not have to simplify your answer. So that's pretty, I think you'll, pretty easily be able to do that. But if you get mixed up on anything or have any questions, just email me. Part two, the vibrating string. This is also pretty self-explanatory, but did want to point out some areas in which students typically, like most commonly, make mistakes. The grades are typically really good on this project, but there are a few mistakes that I've seen, time and time again. In part A, you're going to graph the displacement function, which as you can see is right here. You're going to graph that displacement function, and you're also going to graph these two functions in part A. Now, when it says how are these graphs related, you need to relate all three of those graphs, not just two of the three in any random two of the three. Make sure that you discuss the relationship between all three functions as viewing the graph. In part B, it says use the graph to estimate the maximum value of the displacement. So really I would say on part B, C, and D, make sure that you really zoom into the graph so you can get a good look at the behavior at, say, a local maximum or local minimum, or the time after which the displacement is no more than 2 centimeters. So yeah, I don't know really how else to give any more hints without giving the answer, but just be really careful in evaluating those graphs, and you primarily use the graph. Then if you want to find an exact value, then you can come back up here and use these functions and plug in t or plug in y and solve for t to get the exact value. But I found that for me, it was easiest to use the graph and then verify it with the functions. And as you know too, with things like Desmos, you can easily zoom in and just click on a point and it will tell you the exact point. So if you end up using a method such as that, just provide screenshots of your reference to that Desmos graph. All right, hope that helps. Let me know if you have any questions by contacting me at my email address. Thanks a lot.